Hey everybody, we are going to talk about the last two sections of factoring today. 8.7 is factoring special cases and 8.8 is factor by grouping. Both of these sections are pretty easy. 8.7 is easy if you can find perfect squares. 8.8 is easy if you can find the GCF. And we already did that. So let's talk about special cases first. So if you remember, when we multiplied, we talked about having the same two terms squared or the same two terms with a plus and a minus in them, and what special patterns we got from that when we FOILed those specific special terms out. Remember, we're factoring, so we're going from the trinomial backwards this time. Same thing over here, we're going from this binomial backwards. So all of this is going to be about recognizing perfect squares. Let's start with our perfect square trinomials. So how will you know if it's a perfect square trinomial? Well, first, the first and last terms have to be perfect squares. So your first group and your second group all have to be perfect squares. Remember, your perfect squares are 1, 4, 9, 16, etc. And x squared is a perfect square. The middle term then is going to be 2 times the square root of your first term and the square root of your last term. So if you look here, in my first example, I have x squared plus 14x plus 49. Square root of my first term is x. The square root of my last term is 49. X times 2 times 7 is 14x. That gives you the middle term, so I know this is a perfect square trinomial. So once you have identified it as a perfect square trinomial, finding the answer is quite easy. You take the square root of the first term, square root of the second term, and then write it as a squared group. Remember, the sign of the middle term, plus or minus, tells you the sign that shows up in your parentheses. So in the first example, square root of x, square root of 49, 7, and I know it's plus 7 because it's plus 14. In my second example, the square root of 4x squared is 2x. The square root of 25 is 5. I know it's a minus sign in the middle because it's minus 20. If you look at your difference of two squares, there's a couple of things you have to check besides the perfect squares. You have to check that they're both perfect squares, but that they are subtracted. If you have x squared plus something, that is not going to be the difference of two squares. You cannot factor that. So you need to make sure that it's always a minus sign if you're going to do the first thing squared minus the second thing squared. And remember that that middle term only cancels out because we have different signs in our parentheses. So when you write your answer for this difference of two squares, you are going to have two parentheses as part of your answer. It is not going to be a little squared as part of your answer. So you can look over here at these examples and you'll see x squared minus 9, 16x squared minus 25. Now, I'll talk about that last one in a second, but those first two are all perfect squares, x squared, 9, 16, 25. So that kind of gives me a heads up that maybe this is one of those difference of two perfect squares. Notice also they're all subtraction. So how do I find the answer? Well, it's really easy. Take the square root of the first thing, so x, square root of the second thing, 3, and then you have 1 plus, 1 minus. Square root of 16x squared is 4x. Square root of 25 is 5. 1 plus, 1 minus. Now, in this last example, you might think that it's not really a perfect square trinomial because 45 and 20 are not perfect squares. But remember, you always need to look for a GCF first. So if I factor out a 5 from both of those terms, then I get 9x squared minus 4. And 9 and 4 are both perfect squares. So I can continue to factor this inside binomial further into 3x and 2. I have 1 plus, 1 minus, because that's how I get that middle term to cancel out. So the total answer for 45x squared minus 20 is 5, parentheses, 3x plus 2, parentheses, 3x minus 2. 8.8 is all about factor by grouping. And factor by grouping is really easy because all you have to do is find the greatest common factors, which we already know how to do. We did that very first when we started factoring. Factor by grouping usually has 4 terms, and basically you're going to turn that into 2 smaller groups, and from each group you're going to find the greatest common factor. So the steps are group into 2 groups of parentheses. Each group should have 2 terms. You have 2 groups of 2 terms. That should make 4 terms total. Factor out your greatest common factor from each group. And when you do this, it's really important that the parts that are left over, the non-greatest common factor parts, are the exact same in both parentheses. You'll see that in my example. If they're not the same, then you have not found the correct greatest common factor if it's a factor by grouping problem. Then once you're done, all you have to do is rewrite your answer. Please note that you're going to write the two greatest common factors together in a parentheses, and then you're going to write the repeated parentheses part just one time. So let's take a look at our example here. 15q to the third power plus 40q squared plus 3q plus 8. So the first thing I do is just group them with two sets of parentheses. So I put a parentheses around the first two groups and a parentheses around the second two groups. That's step one, add all the parentheses. Then I basically go through and treat each problem like a separate item. Maybe I'll cover up this second half and just say, okay, in these first two groups, what are my greatest common factor? In the first two groups, the greatest common factor is 5q squared. What I have left over, or what would make 15q, is 3q, and then plus 8. So this 5q squared plus 3q plus 8, or times 3q plus 8, is what I would get if I just did the factoring for those first two terms, the greatest common factor of those first two terms. In this second group, they really have nothing in common. So I'm going to write a plus 1 and then leave my 3q plus 8. And notice that when I did my greatest common factors, the greatest common factors are out here on the outside, what was left over is the exact same in both groups of two parentheses. So 3q plus 8 was left from the first group, 3q plus 8 was left from the second group. That means I did my problem right. Now all that's left is for me to rewrite my answer. When you rewrite your answer, you put your greatest common factors in a parentheses together. So 5q squared plus 1 goes in the first parentheses. Those are my greatest common factors. And then what's left over is 3q plus 8. Please note that you're writing that only one time because essentially you're factoring out that whole binomial. So you are not writing two groups of 3q plus 8. You are only writing one group of 3q plus 8 and then one group for the binomial of greatest common factors. Remember, with all of your factoring problems, if you are working and you're not sure if you did it correctly, you can work backwards. Go back through and multiply your answer and make sure that you got the original problem that you started with. So here I could go through and multiply this back out and hopefully get the original four-group polynomial that I started with. The last thing I wanted to tell you or show you guys today is this little flow chart. It might work for some people, it may not work for everyone, and if you don't use it, that is totally okay. But the flow chart kind of gives you an idea of all of the things that we've talked about here with factoring and all of the things you need to look at when you're looking at a factoring problem. So if you're given a polynomial and it says factor this, here are the things you should ask yourself. Number one, does it have a GCF? If it does, you need to factor out the GCF and look at the rest of the polynomial that's left. If it doesn't, keep moving on. The next thing you look at is how many terms does your remaining polynomial have? Does it have 2 terms? Does it have 3 terms? Does it have more than 3 terms? If it's 2 terms, that's going to be one of those special cases, assuming it's subtraction. If it's not subtraction or perfect squares, then you're done. If it's 3 terms, you have to check and see if it's one of those special cases. And if it's not, use your regular factoring or your guess and check or your slide and divide or your box method. That would be for 3 terms. If it's more than 3 terms, it should be grouping. So that's kind of a little chart to help you, if you need it, work through your factoring problems and figure out what to do. Your assignment today is to finish all this special cases and grouping practice. Answers will go up tomorrow, and just completing the worksheet, not for accuracy, but making sure that you complete it and show your work. That will be your grade for Monday's class. You just have to finish it before we have class on Wednesday. Any questions, feel free to email me. Thanks.